In my last video, I had a comment that has mysteriously disappeared express interest in the implementation of the LSP that I shared in the video. I'm not sure what happened to the comment, but I appreciate its brief existence because it gave me an idea for the next video, this video. So I'm going to go over the implementation of the LSP. Just not too deep, but enough, I think. I have a little diagram, a big diagram, a diagram. So let's pull it up. So in the diagram, you can see a green little square, and that green little square is the client or your code editor. As you can see, it's sending messages to Big Orange. Big Orange is the server. If you are familiar with web development, I think the server might look familiar to you. There's a handlers section and a state section. Handlers being analogous to endpoints, and state being the state of the server. State has 4 fields or categories or subsections, whatever. Documents, burns, models, and a database connection, if you want one. Documents are basically just the internal representation of all of your code documents. Models are the 2 models that the server has available to it. Right now, that's just a summarizer and the actual assistant itself. And then burns are what I'm calling commands because, they get burned into the document. That's kind of where I was going with it. Burns can either be multi-line or single line, and they all have their own logic in terms of what they do when they're activated, how user input is or isn't parsed relative to the location of a burn. And they're also all stored in state with the document they are attached to and then the coordinates of the burn in the document. Finally, database is the newest feature and most experimental feature. Basically, if you want to, you can opt in to the database feature with the configuration file. And when the server is spun up, it'll also spin up another child process in its own thread of a SurrealDB instance running. In order to use it, you just need SurrealDB installed. You opt in, and it'll just spin them up. Eventually, I think this feature will be more important because it's how I'm going to be driving all of the vector embedded searching. But for now, it's mostly experimental. So that's it for state. Pretty simple. Handlers, on the other hand, are, like I said, analogous to endpoints in a web server. The handler is equipped to handle any LSP client request or notification. I think in a different video, I'll go over what an LSP actually is, or what the LSP, because it technically is a protocol. Calling my application an LSP is a little bit of a, misuse of the word. Anyway, so the handlers can handle potentially any request that fits into the language server protocol specification. But right now I only have 6 handlers. So 5. There's the notifications, which are simply did save, did change, did open. Did save is whenever a document is saved. Notification containing the document that was saved and its entire text contents is sent to the server. Did change, whenever anything happens to a document, the notification is sent to the server with the document URI and the coordinates of each change. Did open is whenever a document is opened. Pretty simple. I've got pretty similar logic for each of these handlers, mostly just updating the state based on changes or saves or, opens, and then diagnosing the new state of the document so that the diagnostics are all up to date. The 2 LSP requests that I have support for are hover and go to definition. Hover being when you hover over something, go to definition being when you leader GD or whatever it is that you VS Coders do. So each of these handlers for the hover and go to definition are also pretty similar to each other. Basically, given these coordinates and the document that this happened on, is there a burn that exists within these coordinates on this document? If so, either activate the burn in the case of a go-to definition or just return hover contents if they exist in the case of a hover. Finally, if you take note of the directions of these white arrows, you'll notice that you have notifications and requests getting sent to the server handling it with the handlers and state, and then references to something called a buffer operation. A buffer operation is an abstraction that I created because LSPs usually have a single request, single response type situation going on. But in this instance, if you think about how I'm handling something like a go-to definition, I'm not really using it actually as a go-to definition. I'm using it as a button click in a way. You know, you can imagine that instead of go-to definition, there was some button that said prompt the model, and you clicked it and then things happened. If you think about the quick prompt, just from the single go-to definition request of, you type in your prompt, you press leader GD, and you trigger the LSP to actually prompt the model. First, the text is removed from the document, so that's one response from the server. Another response is in the bottom right-hand corner. You'll get a little message saying, all right, we're prompting the model. And then every single token from the model's response gets sent to the client. And then finally, when the message is finished, you get a different kind of message with the whole message in the client. So for one leader GD, you can have an arbitrary amount of responses from the server. So I needed to write basically another channel that exists in the server to send what I've been calling buffer operations, because they're operations on your text buffer. They basically are just a wrapper around LSP messages, and it allows me to just send as many LSP responses as I want for any given LSP request. Yeah, that's pretty much it.